Good, good. I found the trouble. And it is a trouble too.
Do we all have to take the test?
It's personal.
Oh.
I don't have to take the test, the rest of you guys do.
There's been a fundamental incomplete understanding. No need to bring it up.
I was going to flip it around so I can see
No
it.
need.
Okay.
That can make a difference here. Yeah.
Are you causing trouble?
We're okay now. Don't we look okay?
I don't know. No,
I mean, for the 8th week of the Calculus 3 course, don't we look?
No.
Even just to be talking. Okay, what we have come across, and back in section 13.7, is a very potential trap. I realized it at that time, and it slipped my mind in the meantime, and Stuart led me back into it tonight, and I went right along willingly. But it's a big trap, doesn't work, and we're going to find out why. Okay, so class has to start yet, though. So, that was a very good thing to have spent the 5 minutes before class on it.
The 5 minutes before class,
Yeah.
since 5 o'clock yesterday afternoon.
Yeah, well, it's going to be worth your time when you see the distinction, time well spent to have focused in on this, and you refuse to let it go unresolved, which was good. So you're going to find out a very good point that we're going to resolve this. Okay, so let's start the class. Now, this will be our last class, and the idea of tonight's class is to solidify your problem sets, starting in 13.7 all the way through 15.1, and make sure that you have everything that you want and need. Particularly, we're going to focus on, I believe it's 14.8, which is triple integrals in spherical and cylindrical coordinates, because we didn't put those in the whiteboard yet, and I'm going to do a little presentation when the time arises. But Stuart has pointed out a misstep in doing a problem way back in 13.7, and since it's arisen, then I'm going to illustrate the right and wrong of this situation. Okay, if we are given a starting function called x squared plus y squared plus z squared equals 0, equals 25, right? Okay. Now, there are two ways that you can interpret this function. The way you don't want to interpret it, because this is in section 13.7, which is dealing to tangent planes to surfaces. We want tangent plane to a surface. So what we don't want to do is say that this is a function in xyz space that has some result, say a temperature. Say the temperature at this point, x, y, and z, is x squared plus y squared plus z squared equals 25, true? Temperature over here is x squared plus y squared plus z squared equals 25. So the temperature everywhere in the room is given as a function of x and y and z, agreed? So now at this point, the gradient is going to point in the direction of increasing temperature, agreed? So the gradient is going to point in the direction of increasing temperature. Now, we can also, so this is one interpretation, a point in 3 space. So the other interpretation is that z is some function of x and y. So z is a surface. So in this case, the normal to this surface points outward from all of the possible curves that you can draw inside of this surface. So this normal has no relation to this normal. This is a vector that's normal to a line of constant z, not normal to a line of constant temperature, which includes all three variables. This is a line that's normal to two variables. The gradient is normal to all three variables. So the gradient is not the tool that we want. The gradient points in a direction that's normal to the function including all three variables. What we want is a vector that's normal to the surface defined by the other two variables. So we want to work on page 973. So this is the equation that will describe the tangent plane at the point z, at the point x0, y0. And it comes about by dotting the gradient. We take the gradient it's coming about the same. No, it comes out exactly the same. Okay. Nope, comes out exactly the same. Z equals, well, let's put in these numbers and see if we produce any difference. So let's look at the equation 5 on 973. So, and this, now let's turn the board around and get our numbers. Okay, so the point at which we want is 304 still?
Yes.
So point equals 304. Okay, so if we do it by using the equation z equals f x0 y0 plus f of x minus x0 plus f of y minus y0. Now f of y is 2y and y minus y0 is y minus 0. Okay? And f of x is 2x, and it's x minus 3. And the function evaluated at x0, y0 is going to be 9 plus 0
Square root of 25 minus 9.
The 25 is the difference.
Why is it 9 squared?
Because x is 3.
So, function.
Oh, x is 3.
Z equals f of x. So let's solve, we have to solve this equation for z.
Z equals square root of
So
25
so
minus
z equals the square root of 25 minus x squared minus y squared. So this point evaluated at our point is square root of 16, or 4, right?
Yes.
Yes.
So this is equal to 4, z equals 4. So this is the equation for our plane. So the equation for the plane is that z, okay, that's not going to equals 4 plus,
Just like you can get any of
it's not
them,
going to come out linear. Oh, this has to be evaluated at the point. These are evaluated at the point also. So this is evaluated at the
No.
point.
right? So this one should be like the
At
easiest one
3,
possible.
there's going to be 6. and this is
Of
gonna
that
be
section, yeah.
8. Okay. So the C equals 4 plus 6x minus 18 plus 8y.
I didn't use the
So
formula.
Z
I got 2y getting
equals 6x plus 8y.
When you plug in 0 for y, it should go to 0.
Yeah, yeah. 8.
Oh, never mind. Yeah, because you're evaluating the whole function.
Huh?
You're evaluating the whole function there.
I don't know, I didn't use the formula, but I got the answer.
Some of us are
Yeah.
just born knowing things.
No,
So-
only that section, trust me. I still haven't done
Um,
anything else.
So explain to me what it is.
Yeah, that should be
It should be 0.
0.
6x minus 3, 6x, so, let's do this again. 6x minus 18 plus 8y, true?
0y. Because when you plug in 0 for y, 2 times 0.
9, 0 for y.
That was AJ's fault. He caught it.
Okay. So, we don't have any y in the plane at all? Hmm?
I do.
Well,
I
I
have
should
a
think,
y.
I should want us to. So let's see.
I don't know if it's right, but I have a,
Y goes to 0 the way I've been doing it as well.
oh, I have the wrong thing, I haven't done that one.
It should only take like 30 seconds.
Yeah, I can do this section, I can't do
This is number
anything
3,
else.
right?
Yes.
So,
I can do
apparently
that.
what we
It
get
just doesn't
is
match the book.
z equals 6x minus 14 for our plane.
Here, let me see.
Z equals 6x minus 14 for our plane. Does that resemble any of your answers?
So that
We didn't even do number 3, did
No.
we? Okay, that's that.
But it's just, like, you could have picked any of the problems. Number 5, I get different answers for. I just get different answers across the board.
Well, what's your answer before?
My answer for number 4 is,
Just so I can compare to my answer.
I have x, negative 6x plus 9y minus 16z equals negative 5,
You have negative 6x.
plus 9y minus 16z. And then for the normal line, I have x equals negative 3 minus 6t, y equals 1 plus 9t, and z equals 2 minus 16t.
Yeah, that's exactly what I got. That's all wrong?
I get the odd ones wrong.
Well, what about the even ones?
Oh.
So I have,
I see what's different.
I have 6x minus
Okay,
3
I see
plus
what's
8z
different
minus
now.
4.
Okay,
Is that wrong?
I'm going to restart my solution. I see where my solution went south. F of x is not what we think f of x is. Now, what I want to do is see why this solution with a gradient doesn't yield the same answer. The function of x, y, z equals 0 on the surface.
Okay, that's
So
what I
we
did.
have the gradient
That's
Um,
Oh, no, that's what I
as
got.
normal. So the tangent line
Until solved.
equals 0. And the normal line. So the tangent line
So I don't
and
know.
the parametric equations. Now, in this one, are you asked to find, yeah, you're asked to find the parametric equations as well.
Well, it looks like they divided the whole equation by 2.
That's
Like,
okay.
if you take yours and you divide it by
No,
2.
mine has an error in it, I have to
Down
restart mine.
at the bottom, 3x plus 4z equals 25.
Yeah.
We can't, that is mine being reduced. They have 9 there.
I don't
No,
mind.
that's what they have.
I don't
3x
mind
plus
if they
4z
scale
equals
differently,
25.
as long as they can be scaled. Because t is an arbitrary parameter, as long as it can be scaled.
13.7, right?
Yeah.
Hmm.
That's page
Number
9.
3, 13.7.
Your book is different than mine.
3x plus 4z equals 25.
Are you kidding me?
No, that's what I get if you reduce it. There's no reason to reduce it, but that's what I get. Tangent plane, 3x plus 4z equals 25. 3x plus 4z, I don't know where that negative 9 is.
3x minus 4z equals negative 9.
I get 25.
No, look,
I know, our answers are completely different.
They're on different-
Same section, same number, tangent plane, but different answer.
and different page.
What'd you do, print your own book?
Apparently.
So your answers are wrong.
No wonder your answers are always wrong.
Yeah, apparently.
But I
Is
thought
Is that a Xerox book? Is that a black market
it might be
book?
because he got.
What
You know what?
I-
It's
where'd
you
you
know
buy
what?
it?
It's not the same book. This is not international. It's combined 9. Mine's international.
There you go.
What's your ISBN?
I don't know. What is, and mine's 10. Yours is 9th mixed.
I thought we were
Yours is
supposed.
combined.
I thought we were supposed to get the 9th one. I searched for the ISBN. I
Right,
sort of.
we're in 10th edition, dude.
Oh, well, that explains a lot.
So
Well, I'm glad we found this out early on in the course, so we don't have 8 weeks of
yeah,
misery.
the last day. But I thought that if you reduced it, because I can reduce it and get to 3x plus 4z, but I thought if you reduce the whole equation, oh, you had 50 at the end. I had 25 still.
Okay.
Why does it go to 50?
Because, well, I can explain my answer on the board now that I'm apparently right.
Yeah, it's right, but why does it go to 50?
So, here's your end values.
Yeah.
Plug there, there.
Yeah, I got those.
And then the points are here.
Mhm.
So 8 times negative 4.
Oh,
6
you
times
distribute
negative
out. Okay.
Yeah,
All right.
that's where it comes from.
All right. Got
Okay,
it.
now the reason this approach didn't yield the same thing is because f of x is the derivative of f. It's not the derivative of this, which is capital F. So small f is what z is equal to. This is capital F. So what I did was I took capital F of x, and as we would for the gradient. But in this approach, you have to take the derivative of small f, which is the square root. And then we would come down to the same answers, because the approaches are valid. So the two approaches give the same answers. So it's not a question of do or don't do. You can do either one you want. You just don't buy a 9th edition book.
This is the second class that I've taken that I ordered a specific ISBN off of Amazon.com and they sent me the wrong version. Like, I don't search by name, I search by...
No, they're just being careless because they don't want to have
Well,
have
you also
useless books on
didn't
their
pay
shelf
what we paid for our books.
that are obsolete.
I paid
So,
48.
Yeah, I
They're
paid
ripping you
$100.
off. yeah,
I always have a problem with shipping books. With
they're
them.
selling
I
older
always buy
books.
stuff, it's always the wrong one.
Mm.
I just have to set so many logos back.
I just buy from Yuma because it's just.
Okay, so what we've got here for you to do take a look at. Last class, or thereabouts, 2 classes ago, I distributed part 1 graded points for your test 2, and promised you that part 2 would be forthcoming on the grading. So what I have graded for you now is the multiple choice feed part of part 2. So you can look at the multiple choice part of test 2, and the maximum points were 69. So easy for yours to keep. So I have yet to grade those short answer questions, 13 short answer questions, which are still the last segment of that test.
I thought you gave us those.
No, I graded the textbook part.
What short
Oh.
answer?
The last 8 questions,
The last 8 questions or so.
it went to,
Oh. The ones where we actually had the right answers. Oh,
Yes.
yeah.
Right. So that's yet to be graded. But I do notice that people seem to like these multiple choice questions a little bit better than you like the textbook questions. So once again, the jury is still out, depending on what you do on Friday, can change grades quite a bit. Given this folding in of these multiple choice scores with what you did previously, and knowing that Friday's test is totally predictable, it's in your control, then it gives you the opportunity to go shoot for the moon. So let's see what comes of it. So I do want to find out about the times. Generally, we start at 6:15 on Friday, and we go until 9 o'clock. I've already indicated I can stay until 10, but people still might be fearsome and might want to come in prior to 6:15. How many people would be fearsome and want to come in prior to 6:15?
I'll come in at 9 in the morning,
I
and I'll leave at 9 in the morning the
was
next
planning
day.
on showing up at 4.
4,
Because
okay.
you'd said that.
Is 4 is possible? I just want to be sure somebody's going to come show, that's all. I don't come here
I'm
and
planning to show
sit.
you.
Oh, I can't do 9? Darn.
You can do 9, let me know how it goes.
Just steady in the hall.
No.
Okay, so
Sitting
we'll
in
start
the
at 4, and we'll stop sometime around 10. Oh, and also, I will be here from 2 to 4 the next day. I have to come in, these algebra students are making me come in. So if you really want to be conservative, we can do it a page at a time, and you can postpone some of the pages until Saturday. How many feel that they might want to do that? Well, okay, I can set up the page, test the page at a
She's
time.
gonna be here anyways, that's cheating.
I know.
See what?
She's gonna be here anyways, that's cheating.
Yeah, well, she's gonna have to teach algebra. She's not gonna have a chance to do any calculus on Saturday. No, they're just testing on that Saturday, so there's no need for tutoring. Okay, so what I'd like to do now is remind you that if you have a rectangle that has a width, a length, and a height, that the volume of the rectangle is what? Okay, does
Big.
everyone agree that the volume of a rectangular solid is length times width times height? We all agree to
It's
that.
the triple integral of dv.
Well, we're getting there. You see, he knows what's coming. He knows exactly what's coming. Okay, so now if I have
Is it in your
a-
calculator?
now, if I have an XY space, XYZ space, if I have an XY space, then I've drawn lines here of constant what?
Length.
Why?
X. They're constant
Yes.
X, agreed?
X, yes.
No, those-
X is everywhere the same. So if I want to indicate a change, then I have an infinitesimal vector that goes in the direction of increasing variable and is perpendicular to the line of constant value, agreed? That little infinitesimal we call dx. It points normal to a line of constant value of x. and it's infinitesimal in length. Similarly, I can have a little infinitesimal dy. Now dy times dx gives you a dA, called an area. Now if you go to 3 space, then you get a dy, you get a dz, and you get a dx. And these combine to give you a parallelogram. So what is the volume of that parallelogram? Length times width times height gives you what?
dx, dy, dz.
So when you start off with the integral of any function over some volume, the first thing you write down is dv, which is generic. dv is an infinitesimal volume in 3 space. It has no infinitesimal variables on it until you choose them. So dv is generic, and you get to choose what your infinitesimals are going to be, depending on what you feel is the easiest coordinate system to work the problem in. So now let's look at another rectangular solid. Suppose I have a rectangular solid that has these dimensions. Suppose this is dz, and this is dr, and this side is r d theta. If those are the 3 sides of my box, then what is the volume of the box?
dz, dr, rd theta.
Right, it's dz, dr times rd theta, agreed? Property of 3 sides. Now why is that rd theta? Because if you go back to the z-axis, and this is the angle theta that is in the xy plane, so this is the angle theta, so a little d theta is a change in that angle, so this is d theta. But d theta is only the change in the angle. And we know if you have a circle, and you have a little change in an angle d theta, and the circle has a radius r, then what arc length have you created?
Already
rd theta. So that's why if we have a radius r and a little increased d theta, we have created a side of a rectangular box called rd theta. And the volume of the box is the product of the 3 sides, rd theta, dz, and dr. So in rectangular coordinates, our little dv, our little rectangular box, the product of the 3 sides, is rd theta, dz, dr. Now let's try another box. Suppose, let's draw it in a better direction. Suppose I tell you that this side is d rho. And suppose I tell you that this side, or this side up here, is rho d phi. And suppose I tell you that this side here is rho sine theta, so rho sine phi d theta. Suppose I tell you that that's what those 3 sides are. Then can you tell me what's the volume of the box?
Rho squared sine phi d theta d phi d rho. Yeah, it was really hard to pronounce that.
Okay, now why are those the sides of the box? Because down here we have a point of origin, our 3 axes, and we have some radial vector rho that goes up. So this is rho going from the origin. So isn't this simply the increase in rho? That's very clear. Now up here we have some angle phi. Now, we have some angle phi that comes down from the top, agreed? So this is d phi, is it not? Now, this distance here is a part of a circle. If we have a circle that has some radius rho and a angle d phi, then what is the arc length?
Rho d phi.
So therefore, this side is rho d phi, because it is a change in the angle phi, and it has a radial rho. going back to its point of circularity.
That's not a real story problem, right? Because I have
Beg
no
pardon,
idea
ma'am?
how to read it. That's not a real story problem, right? Because I have no idea how to read it.
Just listen,
Okay.
it's feeling, just get the emotion.
All right.
Don't worry about facts.
Okay, good.
Now, this other side, it's actually down here, the same angle, theta, so it's a d theta. So this third side is an increase in the theta angle. So it has a little angle d theta. So if we go to a circle and we have a little increase of d theta, then what is the arc length? The arc length depends on the radius, agreed? So it depends on the radius of theta, but the radius of theta is a horizontal distance to the z-axis. It's not the angle distance to the origin, because theta is measured in horizontal planes. It's a horizontal angle. So it is the horizontal distance directly to the z-axis. Now, if this is the distance rho, and this is the angle phi, then this side is rho sine phi, because this is a right triangle. So the horizontal distance directly to the z-axis is rho sine phi. So if I have a radius of rho sine phi, and I have an incremental angle of d theta, then what is the arc length that's swept out? It's the radial component times the angular component. And this whole key is that d theta represents an incremental change in the horizontal plane between the projection of rho onto the horizontal plane and the x-axis. That's what theta is defined as. Theta is defined in spherical coordinates exactly the same way that is defined in cylindrical coordinates. In cylindrical coordinates, this was the distance r. You can still think of it as a distance r if you want. It's the direct distance from your point to the z-axis. And it's given as the third side of this triangle that has z, rho, and rho sine phi, where phi is the azimuthal angle. It's the directional angle between your radial vector rho and the z-axis is what z is. So z drops you down directly from the z-axis. So this is where the rectangle comes from. So if you have these sides, let's say them one against. So in spherical coordinates, this is going to be d rho. This side is going to be rho d phi, because it drops down. And what's this horizontal side going to be? So when you have dv in these coordinates, you're going to get rho squared sine of phi d rho d phi d theta. So that's where it comes from, because the volume of a rectangular solid is the product of the three sides. And we show by geometry and trig that these three sides, in terms of these variables, are rho d phi, d rho, and rho sine phi d theta. So when we product them together, we get the infinitesimal volume dv. So that's really all you need to know to work all these problems, yes, sir?
So in x, y, z, it's just the three dx, dy, dz. In polar, it's r, dr, d theta.
dz, d phi, d theta.
dz, okay.
dz, yes.
Okay, so that's cylindrical. And then this is rho squared sine phi, then the three.
That's right. That's right. That's what they are. And you have to know these as well as you know your middle name, so that you can just write them down without thinking. Absolutely right. Now, I've also thought of a better way to aid you in the visualization,
My middle name.
the visualization of these shapes that you're trying to find the volume of. So if we go to 14.8,
Does anyone have a page number?
I will in a
1075.
moment. No, it's not 14.8, I guess it's 14.7 or 6 or
14.6.
14.6.
It starts at
At
10:48.
1048.
The problems?
No, the actual section is 1048.
Well, let's go to 10.56. Um, now let me look at problem number 19. 105.7, number 19. So, the given problem is 0 to 2, and the next integral is x equals 0, x equals square root of 4 minus y squared, and then the first integral was that z equals square root of x squared plus y squared, and it stopped at z equals square root 8 minus x squared plus y squared. I find that it helps incredibly if I write down what are the limits that I'm working with. This last one is y equals 0. It's the last one I'm doing to y equals 2. And so the expression that we're actually evaluating is z squared dz dx dy. And our instructions are to choose your poison. Pick your poison. Do you want to change this to cylindrical or do you want to change this to spherical?
Sure.
You must change it to something, so we'll change it to cylindrical. But the thing not to do is to simply start translating limits. You can do this, but it cannot yield gold also. So what you do want to do now, if at all possible, is to reconstruct the volume figure, to make a drawing, at least mentally, if you can't do it artistically. So first thing I'm doing is I'm integrating z from a lower limit described by this function to an upper limit described by that function. So what in the world are these functions that we're talking about? Well, if you look at this function, I think you recognize that that's a sphere. We all in favor that that's a sphere? So the upper limit is going to be a sphere. And the lower limit is maybe a little bit more quizzical. So one trick that I stumbled upon just this afternoon as a way to help the visualization is to draw the profiles. We have x, y, and z. Instead of trying to do the things all at once, just do one cross section at a time. Let's see what this looks like in the zy plane. That's the back plane. Let's see how the zy plane slices our volume. Let's take a cross section at that point. This point is identified by the signature x equals 0, is it not? So in other words, our equations are going to condense to a lower one of z equals square root of y squared, or just z equals y, true? Which is very familiar. That's just a straight line, z equals y, agree? That's the line z equals y?
I don't know. Why did you say x equals 0? Is that because your x limit is 0?
No, because what I want to do is now make a graph of what this volume, it's a three-dimensional volume, would look like if I sliced it in the
Okay,
yz
so you
plane.
want it in the first quadrant. In essence.
No, I don't have to. I can put it all the way down if you want. Just sort of looking ahead. So it goes all the way down. So this is my lower limit of integration as it looks in this plane. Now this plane is delineated by x equals 0. Isn't x equals 0 true? what's the value of x equals 0 in that plane? X in the YZ plane. What's the value of x?
0.
Right, so that's why I put 0 in my functions.
Okay.
So, point.
Would it be square root of z equals 1?
Yeah, but square root of z equals y, I don't think so.
Square.
I don't think so. Let's try the algebra slowly. Put in a 0 for x, and you get z equals the square root of y squared. And the square root of y squared is
Okay.
y.
Okay.
I know it's late. Okay, good. Now let's try the upper limit. In the upper limit, if I put in 0 for x, I get equals the square root of 8 minus y squared. And that can be rewritten as z squared plus y squared equals 8. Now, do you recognize what that is describing? It's a circle, is it not? It's a circle? So it's a circle, so it looks like this. So this is what the function looks like in the z plane. And what I have to do is take this line as my lower limit, and this is my upper limit. So I'm going to integrate over that region there. At this point, that's all I know. Okay? Now, if I go into the xz plane, if I go into the xz plane and ask what that looks like, then I'm going to set y equal to 0. If I set y equal to 0, I get the line z equals x. If I set y equal to 0, I get the same circle. So this thing looks exactly the same. Now, if I go down to the floor, for the xy plane, I'm asking for z to be 0. So z equals 0 means that x and y are also equal to 0, agreed? So it comes down to a point. The other thing that's true is that if z equals 0, in this equation, we have x squared plus y squared equals 8, which is the equation for a circle of radius square root of 8. So now looking at these three projections, sir.
Oh, never mind, I'm good.
Looking at these three projections, and now they both equal down as aids in visualizing what this is going to look like. So now let's look again. We have z equals 8 minus x squared plus y squared as our upper limit, and we have z equals the square root of x squared plus y squared as our lower limit. Okay. Now, what that's going to generate is that we have a cone.
It's x squared minus y squared on the top.
It is. Parentheses.
Oh.
I like it that way because then I notice it's r squared all the time. So this is the line. This is known as z equals r. Is another way to write it. Agree? Z equals r. Well, z equals r is just a cone where you go up z and over r and they equal to each other and you have a revolution. So what we're looking at here is the equation of a cone. Z equals r. Agree? And the angle is 45 degrees.
Is it always 45 degrees?
If z equals r, it is.
Okay.
If z equals 3r, then it's not 45 degrees.
Okay.
Now, the other thing that we've noticed is that the top of the cone is like ice cream. It's a part of a sphere. Isn't that the equation of a sphere? And this is the sphere that has a row of what? The square root of 8, agreed? So what we have is our volume. We now have a picture of our volume. It's an ice cream cone with ice cream on the top. Z equals R. Now that you have the picture, you can, from the picture, write down your limits in spherical coordinates, in rectangular coordinates. Now, my z limit is going to go from here to there. That's my limit on z. First I'm going to do the dz. First the function has to be there too, so I'll put in the function in a moment. But the dz is going to go from here where z equals r, agreed? It's going to go from up here to where z equals the square root of 8 minus r squared. So now, just working from the picture, I know that dz goes from r to the square root of 8 minus r squared. Now, if I want to integrate dr, what you have to do is you have to go to your footprint. Your footprint in the xy space. So dr comes down to the footprint. So what's the footprint of this in the space down here? It's a circle, is it not?
Right.
And the radius of this circle is
2.
this point. Well, you don't know what that point is until you algebraically solve for the intersection of these two surfaces, agreed? Let's solve for the intersection of these two surfaces. Z equals r, and z equals r is going to intersect z equals 8 minus r squared square root. So where they're equal to each other is the z value of our, or the r value of our termination point where we stop. So you just do the algebra on that.
Why do you have z equals r? Never mind.
Because the bottom equation is x squared plus y squared, the square root of it is r.
Good.
But I think it's just r, it's not r squared, right?
So
That's right.
That means you're
You have an r squared.
Where?
right above it.
That won't work. I've tried that. Just checking.
I get by with a little help from my friends.
Sounds like that should be a song.
So as Stuart knew an hour ago, r is equal to 2.
Is it a valid step to pull from the xy limits? Like why?
Yes,
Okay.
yes it is. It's a balance step to do that. Okay, so now that we have the extent of the r limit, which is in the footprint, then you can directly do the r limits as 0 to 2, and it is full circle, so the theta limits is 0 to 2 pi. Now, those of you that directly converted your initial variables without benefit of the drawing, you get to the same place.
I did.
You get to the same place without any real knowing of what it is that you're integrating, but you just do a blind substitution and you get to the same place.
Why did you go with cylindrical versus spherical?
Because
Oh,
x
because
squared,
I
y
have a
squared
z.
is circle.
I have a z that I want to keep.
Circle.
I wanted to keep the z because that's a step up, because I don't have to change the z if I go to cylindrical. And I also recognize these r's. So because I recognize the r's and I didn't have to change the z, I opted for cylindrical. Okay, so now it's your guys' turn. So let's start by putting this section up there.
I'm having a harder and harder time identifying my homework. This is 14.6?
Yes. We're running out of rules. So fly to the board and circle your choices. Trample your classmates.
Are we
Challenge, kick.
gonna have graph sketching?
I haven't decided yet. Probably not, because,
We don't all have.
because you will know what you drew, but I won't.
I didn't integrate any of these. I only found their limits. I didn't integrate any of these. I only did the limits in the drawing.
That's the important part, because integration is just calculus 1, so I know that everyone in here can do it. But again, it depends on instructions. What's asked for is what you have to do. So let's get them all this time, because this is our last night.
So yeah, like Stuart, I got most of the limits.
That's the important part.
15, 14.
No, I'm not even sure. some
I'm
of
going to
these-
go to Boston next week, so I have to learn. That's the important part.
I'm not
You
sure
gotta
if-
say pop.
I'm not sure if these limits are correct or not.
Do you already say pop?
Yeah.
People in New York say pop, right?
No, not if you don't want to get shot.
What do you say? You don't say soda.
You don't say anything to anyone.
That's not true.
You say drink.
When my wife and I went to New York, I thought they were all incredibly nice.
I thought so too.
Like they were just like, I really want to go somewhere else. I don't want to be here. Just get out of my way.
Well,
But
they
if you,
look irritated with each other, but.
but if you like stop and talk to them, they're all super helpful and friendly. And
Alright, AJ, just leave me an easy one because I haven't done this section yet.
so you know what the hardest problems for me are? And I've said this every day.
Jonathan?
Quick
No,
check.
the quick checks. The quick checks are my slow checks.
I don't-
got quick check 1A and quick check 2. There was no quick check 4. Yeah. Like you.
Do you have any more? Can I make copies of it?
I don't know if it'll help you, but sure, you can take it all.
I do like noise.
I'll make copies of it, and then I saw your wife today.
Where'd you see her at?
She was at the Mocha
How'd you know she was my wife?
Yeah, that's how I wanted to ask. How did you know it was his wife?
I know Kristen.
All right. So some of this is repeats, and you can
I just
seriously,
made copies of
you
it.
can seriously have well.
No, I
if you
need,
want to.
I started rewriting all my stuff, but I don't know. I'm gonna like fail this test miserably.
So how do you like the new Mokateki?
You know what? I like it.
It looks nice.
The only thing that I think they needed to invest in, and I don't think they did, is white noise.
What?
I don't know if you saw in the corners, they have speakers.
They have speakers to put music in to sound out the noise, but it's just making it louder. They need white noise.
Weird.
I don't
noise is
understand.
Do you don't know what white noise is?
I thought white noise was like elevator music.
what? No, white noise
No,
is
white
the thing
noise-
that blocks out.
White noise is like
Yes,
a
I'm-
static that muffles noise.
Have you never seen the movie White Noise?
No.
Oh, then explain.
Yeah, it's like a static that muffles noise, and so it's what you use in like big open warehouses and cubicle office, big space,
No,
in order
I
to
never have any
muffle
problem
the
with like the
noise.
sound of other places. Not seeing no problem.
Well, because what
Must
they,
be during
what,
typo drum practice maybe.
no, what Mokateki did, what they did was the double
My
doors
wife.
that used to go into the stage area, and they had the partitions, they put the partitions up, and then they put tables and stuff in there.
Oh.
So it looks really cool, I really like it, but
That was all
It's-
my wife's fault.
what was?
The planning of everything.
Oh, that's not what I heard. I heard it was all Tracy's design.
Really?
Yeah.
Hmm.
My kids were like, Mom, you know Tracy designed the whole thing.
You're friends with Tracy too?
Well, I'm not really friends with Tracy. We don't really.
I
We're,
think
They-
I would have been
neighbors
an amazing decorator.
across the
They-
across
they
the
work
street
together.
from each other. I know they do.
Okay.
I know. I know because Taffy got Tracy the job. That's why I know Kristen, because I went to Taffy's going away party, and you guys were there.
I
Really?
know anyone
You were
in
there?
space.
Yes, you were there.
Did-
It was
I
outside
in-
at the lake.
Was I in, were we in Calc yet? Were we in this?
Yeah, we were in our first calc class.
I did
together.
I did not remember that you were there.
Yeah.
I'm sorry. If I was painfully rude to you, it's because I had no idea. It was
I
you.
don't. No, you were mad at me because I wouldn't give you my homework.
Was I really?
Mm-hmm.
I do not. I
It's
must.
okay.
It must have been a really hardcore grudge because I just gave you all my homework without caring.
I know. It's okay.
I take things personally.
I don't really say you guys know people in this space. I've been here for almost 6 years. I don't know anyone.
I try not to know anybody. Yeah, that's when I was in the class with, what's her name in front of me?
Something with the C.
Cecilia.
Yes, Cecilia.
Mm.
I know so many people's names you have to remember, and I can't remember everyone's.
Yeah, and,
I'm bad with names.
and she had the book, and so.
Hmm, a
that's
few
how it
more
worked.
still to do.
Did everyone know that except for me?
No, I didn't know that. So,
Well, you had the book.
what book?
That's why he changed our book.
What book?
Everybody
No,
had the
that was
book.
in Calculus 1 when my friend from the Air Force Academy gave it to me. He told me about it. That was in Calculus 1 now.
I know that guy, remind me of his name.
Sean.
Oh, Kenneth? No, what was it, Ken? Kenneth?
I'm Ken.
No.
No, not you, Stuart.
I actually know several people from
He was in the class.
No, I know
The
several.
weirdo.
No, I know, like, my friends that are well, one of them dropped out, but that were currently at the Air Force Academy.
Are you talking about the seriously smart guy that was sitting back here that had already taken?
Was he in your class too?
Yeah, he was in our
Yeah.
Calc 1 class. Ken,
Yeah.
I think it was Ken.
Wasn't it Ken?
I felt like I was a kid.
I feel like this is Ken over on the side of the whiteboard.
I want to say his name was Ken.
I feel so bad for not remembering, but I never remember. Is this a Y or a what?
Yes.
Okay, well, this is an X. What the heck is that?
I don't know how to do any of this, so I'm gonna pretend like I know what I'm doing.
Until it clicks.
Why should calculus problems have different answers in an international solution than a domestic solution?
Oh, it's because it's version 9 instead of 10.
Yeah, it's the version of it, but
Is it not the
is
same
it because of the measurement?
I think it's because they realized that they screwed it up.
problem? Can't you put that more tactfully? I mean,
I think it's they realized that there's a better way to do calculus.
there you go.
Is it the measurements? Is that why they're different?
No, like everything was the same. They just changed the number. Like it's the equation is the same except for it equals 25 and
I
not
think
9.
you put your finger on it. F stands for up. So we're now looking at 14.6. 4 o'clock on Friday.
The usual crowd shuffles in.
All right, Slaughter's in.
What is VLS? It's not by house, 'cause that.
Can we-
14.6.
Can't we not grade the last 8 problems of
Can
the
we not?
test?
Grade the last 8 problems?
Yeah, just leave the grade as it is.
Are you giving me some foreboding of what to expect when I start to look at them?
Maybe?
I'd say so.
Alright, cool.
No, I'd say you were giving me some foreboding.
Oh, I thought you said, okay, we didn't have to grade it. Like I got it
No,
all.
now you piqued my curiosity. I want to see what
I
being
would like to make
shied
a
away from.
I would like to make a request for a final.
Your final request?
Yes,
A
my
final request.
I want more partial credit. A positive for a negative, minus 3 points. Half. I lost half credit. It's on camera, posterity.
Yeah, I didn't really hit you heavy on that. I thought about it and I wanted to, but.
I thought that was
just hit
heavy.
half. I just hit half.
Oh. Your definition of heavy and my definition of heavy are different.
I just don't think there's any mercy in this class.
Yeah. Well, it wasn't that you made a sign error. If it wasn't a multiple choice question, then you would have just been docked 1 point. But because you chose the wrong answer, I don't really have to look at your work. I can give you 0 because you chose the wrong answer in a multiple choice test. But I found 3 points by looking at your work. That's how it evolved.
I see your point.
Yes,
No pun intended.
yes. You don't see your points out.
It hurts because it's true.
are we getting that little box on our test? Oh,
No, but you
Z
need that little
equals
box.
R
You
and-
need those little boxes to do your test. You mean, am I giving them to you?
yeah.
Oh, no, that's gotta be internal, that's gotta be part of your life from now on.
What little boxes are you talking
The row squared, the
The,
VBs.
the conversions, the cylindrical, spherical, coordinate,
No,
rectangular.
No, those are no.
about? So you won't give me the fact that R squared equals X squared plus Y squared?
I won't give you that, no. I'll
Or
give you the
that-
No,
nerd
that's the
teacher.
easy one.
Is it, what is it, X equals alpha sine? Or-
Something like that. Something like
I
that.
can't
You can draw
remember.
little triangles and figure them out.
It takes so much work.
AJ, are you increasing your height over the last 2 years? You've grown an inch or two since we met.
I swore I shrunk. But
Unless that was that.
I swore
Look at
I
you
should
guys
have been
grow,
shrinking.
No,
You guys
it's
grow.
as we get older, we shrink, and
Oh,
then it
good.
looks like they're taller.
I'll look forward to it.
Okay.
I could have sworn I've been shrinking.
Oh, man, you're looking right over the top of the whiteboard now. I think it's your posture, guy. I think you've learned how to stand up.
What does that mean?
Took you 20 years,
You
huh,
are, you're
AJ?
straight now.
You're straight.
Yeah, you are. Yeah. No, you're standing proud and tall, not
Well,
your height.
I used to stand with more straight back when I was in high school, but that's because of ROTC.
Well, you're back to it now. I guess it's count 3 does it, people.
It's all
Did you
that.
just
It's all
find-
those compliments you've been giving him on his whiteboard work. It boosted his confidence in
Worthy
him.
and deserving of it. This is awesome. I'm really impressed by your guys' drawing ability. That's what I was trying to draw, and look how Stewie just knocked it right out. See that cone with ice cream on top?
Or are you doing 19?
No, he's doing 16, which mine looks something similar. I just don't have the cone part. I have the cone, I don't have the ice cream.
Cone's pretty dry.
Yeah, I'm gonna guess mine is an upside down cone.
Ice cream fell out.
Yeah. So today I had to
I did not hear the word put.
I heard
I heard poop.
You heard poop?
Yep.
No, today I had to put a pill in a pit bull's dog, mouth to swallow it because there was pet sitting for someone.
Mhm.
That was gross. Just to let you know for the record. Did I tell you I have short-term memory?
What?
I have short-term memory.
What?
Tengo memoria corta. No? Sumimasen? I don't know that one.
Would you mind checking my numbers?
All right, number 11. Intersects C equals R squared and a circle of radius 2. The volume consists of 2 portions, one inside the cylinder r equals 2, and one outside that cylinder. They seem to be indicating that you're going to have trouble without a drawing, but still you have two pieces. So the first piece is minus this, and it stops at r squared, and it goes from 0 to 2 pi and 0 to 2. Now the other piece goes from 2 to the square root of 20, and it goes from minus to plus. Now you see, what went wrong was you didn't visualize the
It's in
volume,
here.
so you didn't.
Oh, you
know
got
had
it,
to
okay.
break it into
What
two
number
pieces.
are you doing?
You just tried to convert the limits.
It's a cylinder inside a sphere.
Well,
That's
no,
what
it's
I
not
have,
drawing a
but-
visualization.
And then what do
Um,
you do?
You have
So
to
that's
know what
that's
it
our
is,
square, then
and once you
need
know
the
what
Z
it
line.
is, you recognize you have to
Okay,
break
then
it
that's my
into two
problem.
pieces.
That's what I was trying to figure
Okay?
out.
So this is r squared plus z squared equals 20 is a cylinder, agreed? It's a cylinder that goes straight up, out the x-axis. Now r squared plus z squared equals 20 is a sphere. Okay, that's a sphere of 20, okay? And z equals r squared is a paraboloid. Is a paraboloid, just like this, okay? And, now, this goes up forever. So this, z squared, r squared plus z squared equals 20 is a sphere inside. One inside the cylinder, r equals 2. C equals r squared. 1,
Close.
the volume, and you start, up to 20.
That was 52 and that was gonna get 32. What did this square?
When inside the cylinder, r equals 2. Z equals r squared. Z equals r squared. In a circle of radius 2, the volume consists of two portions. One inside the cylinder, r equals 2. One inside the cylinder, r equals 2. Z equals r squared in a circle of radius 2. This has a radius of square root of 20, which is around 4. So where do these guys intersect? R squared, z squared is r fourth. R squared plus r fourth equals 20. Okay, now that has to be equal to r squared.
That should be 4.
So now you square both sides and you get r fourth, square both sides, r fourth equals 20 minus r squared. So r fourth plus r squared minus 20, r fourth plus r squared minus 20 equals 0. That has solutions, r squared plus 5, r squared plus 5, and r time parentheses, r squared minus 4. Now, these are the only ones that you look at because those are negative. So r squared minus 4 equals 0. So r equals plus or minus 2. Okay, so you know how we did that algebra, right? So this is where they intersect at r equals 2. So this is a sphere, and it intersects at r equals 2. And at r equals 2, then equals 2, it has a certain height. Okay, so we can draw this in profile. Yeah, I'm going to draw it in profile on the front board. So this is section
As long as it's
14.6.
that section should be in two, but everything else is correct.
1056, number 11. So what we have is a circle, and rho is equal to the square root of 20. Then we have a paraboloid, which goes like this. And it intersects at r equals 2. R equals 2 is the intersection, right? And so this point, has r value of 2, and what is it? That is inside the surface of the sphere, but not above the surface, not above the surface. Okay, so they do not want to do this part, they want to do the lower part.
I figured out what the angle is before, but I don't remember how I got it.
So they don't want to do this part. They want the volume that's down here, okay? So the volume that's down there, you have to go from here to there, true?
Yes.
So it has a lower limit here and an upper limit there. So that's your value of z, true? Now that's your value of z only until you come out to here. True? Now after you come out to here, your value of z is from here to here. Just the points in the sphere.
Yeah.
So you see, you had no chance at all of doing this without a
I
picture.
probably should have done
So your integral has 3 pieces. First this piece, and that piece are going to be the same, so you can just double them, right? So what is the limits on z here? The limits on z here is square root of 20 minus r squared, because that's a sphere, right? And to minus, and to its plus
So it's
20 minus r squared. So that's going to be the limits, and that's going to be between, this point here is the square root of 20, right?
Yes.
So it's going to go from r being the square root of it's going to start here at 2, and it's going to stop at the square root of 20. So that's going to be this piece right here.
I think it'd be, how do you get?
Because r starts here, right?
Yeah.
What's the value of r2? And what's the
So it's
value
a
of r
circle?
here?
It's just a flat circle.
No,
with
it's
zero
square
on
root
top
of
of it.
20, right?
And
It's all
from
the
the
way
x,
out.
y, you know that the circle has radius 3.
Yes, I got it.
Okay, good.
And also
Now,
in
for this piece right here,
R is negative, it's still just.
the limit on the bottom is going to be the
Zero to
circle, which
add
is
all
minus
of
the square root of 20 minus r squared.
Do you want me to check?
But it's going to stop here.
Alright, so,
And what's the equation of that is
ignoring the fact that all my other numbers are wrong.
z equals r squared, right?
Yeah, well,
So it's
that's
gonna
how
stop
you do
at
it
R
in
squared.
spherical. I would just need to convert the.
Now the value of r is going to start here,
This is R, right?
and it's going to stop there.
But
So
R,
you go to 2.
R only has a positive value, so it goes from 0 out to the edge. So at any point, it's from 0 to 3. So,
So this which
Well, I'm just doing half of it. I'm just doing this piece right here.
and then the angles, you're doing the full circle.
Oh, well,
There
so you
are
know,
times
when I
that
get to
in-
theta, I'm going to do the whole thing. This
You're
integral,
doing-
I'm doing the green arrows right now. Okay, so
Polar?
the green arrows, this is a line of z.
Cylindrical
It
coordinates,
starts
whatever.
down here, right? Z is,
If you do
minus
0 to
20
2
minus
pi,
r
because
squared.
you're doing the
It
full
stops
circle,
here.
if you're doing cosine,
but the
you'll
equation of
get
this curve
value
is
of
z
0.
equals r squared, right? So it
So you
stops
should
on
do
r
2
squared.
times
Now, the values of r,
equals 0 to theta equals
you
pi.
have to look at the footprint.
That way, you
What's
don't have
the
to worry
footprint?
about, like, if something falls out in the future, you can fix that, and then the z value
the footprint in the XY plane, R goes from 0
Z goes from
to
0,
this line. 2.
and then it goes up to,
Then theta goes all the way around. Theta goes all the way around. So there's no chance to do this one without a drawing. When you get the drawing, you realize the pieces you have to take it
Theta also.
into. Theta also goes 0 to pi.
And this is.
Because this is an outside shell. No, you don't need 2. Sorry, this R goes from, that's a 2. R goes from 2 to the square root of 20, yeah. That's a 2. Okay. Now, and you don't need to double it, because when you do theta goes all the way around, this is a belt. So you get a belt that goes all the way around.
So this plus this.
That's right. 2 pieces. Very hard problem.
I guess I can't do quick number.
Nice drawing. You guys are good drawers.
So, does that make sense? So, like, that's why I started drawing them all out, so I can look at it on a picture, so I can see this is a circle, so I know how much of the circle is being used.
And my drawing is 36. Sometimes I can picture it, sometimes I just can't.
Is that when you go for almond joy? Or not?
Okay, let's see how these are doing.
What's wrong?
AJ, you remember when you
Yeah,
internalized?
you're good at this.
When you internalize these DVs, what was the DV in cylindrical coordinates?
The equation R dr d theta dz.
Right, her R is a little faint, isn't it? Do you think she should make it darker?
Yes.
Well, that's because it comes down here. So are you saying that becomes R squared over 2?
I said, DJ just said
Right.
this in R there.
Well, yeah, it's just an R, but I'm saying that when you take this limit of this equation, it's just that.
Then it's R squared over 2 when you.
Then it's R squared over 2.
That's what he's telling me.
Okay. That's what I'm saying.
That's what friends are for.
You're such a good friend.
I try my best.
So those problems are removed when you start memorizing what these little DVs are. That's why it's required by your intelligent instructor that you memorize these, and he doesn't give them to you, and you forget to write them.
You
But if I
don't-
forget them and give them to you, then you
It's
don't
supposed to
forget
be
to
2
write them.
and that for a quick check
Okay,
one.
so
I didn't have
13
part please.
Oh, you didn't have
rho
basic calculation.
equals something.
Well, my part A doesn't even match. We got
Rho
12
equals
pilots.
0 to 4.
Okay,
0 to
so
pi over 6.
See what's
Okay,
the
those are well done.
answer.
13 is impeccable. 16 seems to have you in a quandary.
I think I what you got.
I know that's what it is, but I don't remember how I got that. So I'm trying to remember.
Maybe that'd
I'm
be
just trying to figure out how to make my drawing
it.
work.
I have these two switched.
Oh.
Like
so
I have the
this
1
is
and the 0 switched, not the thing. I just have this 1 and the.
Like what?
Oh, okay.
Well, what's the shape? Looks like an ice cream cone, isn't it?
Yes.
Because that R still.
Do you just want the volume in it?
Yes. So I'm trying to figure out how far down
Oh.
B goes, and
I
they
didn't
gave
have
me
the integral
Wait, what's the given information?
I'm given a cone and a sphere. I know the sphere at the, here, like, if it were to continue out, would equal 3. So I know
So
it's
a
less.
radius of 3.
Right.
And what's the info on the cone?
The cone is square root of x squared plus y squared.
Equals z?
Yes.
So z equals r. So it's a 45-degree line.
Oh, well, that's how I got it.
Z equals r, it's a 45-degree line. Yeah, you don't go with the 9 for the cone. Well, you found the point of intersection. You need that.
This,
Did you find the point of intersection? Maybe we shouldn't have erased that, because that's going to be needed too. So you know that z equals r is going to be there, but you don't start, well, you want to start with rho. Well, rho is always going to go to 3, there's no question about that. Now, theta is going to go to pi over 4, because this is a 45-degree angle. Because z equals r, agreed?
I was doing it in spherical.
Oh, well, I'm just loosely
Okay,
speaking,
yes.
z equals r
Yes.
establishes that's a 45-degree line.
Yes.
It's a 45-degree line no matter your coordinate system. So it just established it in the most handy one.
Yeah.
So this is pi over 4 and it stops at pi over 2. Well, phi starts here, so it goes from 0, phi is 0 here, so it drops down to
I
pi over
thought-
4.
I have those
When
upside down.
he
Yes.
said,
I actually see it
this
as
is what,
this
from
is
what I
the lower
remember,
limit because it's
when he
lower.
said the last
Alright.
integral, it's always a solid
Yeah, it's
integer.
measured down from the
It's
z-axis.
not?
it's not.
Not quite make it over.
I don't know.
They
But
don't-
it's
One
a
thing
typical
is-
two pi.
Why is,
Interesting
you
enough,
have
they
to
agree
stay
with you, they
here,
go
but you're
up to,
evaluating
I
at
hope
R.
to.
Yeah.
We'll
So
come back to
typically
that in
these
a
two would
moment.
be switched.
But you see, they also
Because
get
this
the
would be
9
the
for
theta
the
integral.
rho squared, which
And
should
that
be
would be
rho
your
cubed.
typical R.
Yeah, the rho 0 to, they go pi over
Yeah, I
4
get the
also to
same
pi
R,
over 2.
and then I get 2 pi.
Okay,
You didn't.
so,
Okay, so this is two pi.
Yeah, because.
Let me
Okay, this is
read
two
through
pi,
it
and
so
this
they-
is 2, right?
they're
So
different
then that is
definitions
one
of
integer.
what
Yeah.
phi is.
It's right here, I don't know.
But we have it, we have
Okay,
it now,
so
right?
then,
Okay,
this
so all you
thing
have to
becomes
do
z
is
squared over
establish
2.
that this line is 45 degrees.
This is my
And,
my
you have
dr, I'm converting my dr.
It was a lot easier for me to establish the first time.
That's
It's
Okay,
not
the
z squared
intersection
over
point's
2,
not
it's just
necessary. But why do they go up instead of down?
But if you find an integral for that, the integral.
It's 1/2. Or it's 3/2.
Yeah, so 9 minus r squared 2 is 3. So it'd be 2z times that all over 3,
Mm-hmm.
but then there's still that r problem. So that has to be. Yeah, she did z first.
I
so
did
she
z
got
first, zr, and then that becomes that, and then your dr d
Wait,
theta.
what?
Because you switch out your, no, this is supposed to be r.
Yeah, that's.
There you
that
go,
makes
there
more
you go.
sense. Oh, well, then that makes that easy, so that, for when you integrate that, that r goes away. And there should be a negative sign in the front. And I think it should be over 6. So
Because
no,
that
I'm saying the
becomes-
full integral of this is -2 this over 6. So
Like that?
that's what the full integral.
Oh.
You're gonna have to evaluate 0, 2. Do you agree?
I got R, then
No, I'm saying the full integral, after everything's done with the integral of that would equal.
Alright, you're here,
Yeah.
and
So,
then we go here.
so pretty much I'm
R,
I'm
this is r,
well,
minus, or r times.
no, I'm solving the
square root.
integral right now, so that's what I'm saying.
Well, but this would be 3/2.
No,
Yeah,
she's
because I-
doing it step by step. What I'm doing is I'm just going straight into what the integral is.
yeah.
Yeah, I am too.
So the actual integral should just be,
9/2, this is 1, this is r, well, if this is r right here,
Yeah,
this is r
this-
squared.
no, the thing is, when
Okay,
you find the
Stuart?
integral,
We uncovered something,
Okay.
another.
when you find the integral of this, and r has
You
to
didn't read the
come
problem
out,
carefully
which
enough.
that would have
So
happened.
could you read the problem
So
again,
the integral of
very carefully?
9
Okay.
minus r squared to the 3 halves.
The
and r will
solid
come out
within
when
the
you do a
sphere.
derivative.
Well, no, r can't come out.
No, that's because that was from its use.
Oh.
Say if you took
Oh,
the
yes,
derivative,
yes.
that's to the R would come out.
Yes.
So phi is
So that's why
correctly
it's minus
defined
infinity.
as coming down
So
from the
just
z
like
axis.
In a
So-
sense.
No, because I think,
Yeah, that's what
I
they
did
want.
that.
They don't want
Switch
what you
this
want.
too, So,
Yeah,
So
these are
shade the
supposed to be
area that they
switched.
want.
This is
Yeah.
d theta.
Oh yeah,
Right.
that's right, you're doing d theta, if you're doing d R. Well, then if it's d theta, theta just comes
No,
out.
the drawing's good, just shade it, shade
Back.
under, shade
It's just
under the
gives you,
cone.
2 pi R.
Okay, so then this is wrong.
yeah.
So,
So pretty much,
Okay.
So
Yeah, all
this
you
one
do is
goes
shade
here,
down
and
there.
then
So
this
this
one
one,
is,
that's
is
what they
still
want.
2, 0.
no, 2 pi
I mean,
is
Well,
zero
no,
to
because
Phi is
I'm now
measured down
integrating
from
this
the
to get
axis.
this.
I gotta redraw it.
No,
All
but
right,
since
good.
there's no pi, you don't even worry about the pi.
Oh,
Since there's no d,
20.
I mean d,
No,
d
it's not
theta.
d theta, you just add d
Yeah.
theta to the end of it.
Yeah,
But we're doing it
oh,
from,
you did.
Hold on.
0 to 2 pi.
9 minus
This is cute.
r squared
Okay.
and then theta,
Yeah, we're not doing it from 0 to 2, we're doing it from 0 to 2 pi.
and then 2, yeah,
So there's, here, and then.
yeah, 2 pi and then 0.
So that gives you 2 pi R d.
Oh, we can, oh, because my pi is in, okay, and then 9 minus r squared,
Okay.
right?
Yeah, now you
Okay,
find,
now I'm on this last one.
yeah.
Okay, so then this gets integrated, my r does. So it's 2 pi r squared.
No, you don't have an R squared,
So,
R squared's not
Jude
necessary.
is repairing,
For this r?
and
Yeah.
illustrating
There's a
very
single angle,
carefully, that's
let's-
nice
okay,
drawing
so-
down.
Let's see
That
this, if you
the
take
angle
the
phi is
derivative
measured
of this,
down
what do you
from the
get?
z-axis. Not
The
up
derivative
on the
of
xy
that?
plane.
Just-
It's 2r.
It's a dogfish.
No,
It's
the
a
derivative
dog.
is
Oh,
square root of
half.
9 minus.
Beautiful
Oh, a
drawing,
half.
Dodgers.
You get a
Certainly
half,
in my top 10.
and then you, oh,
Here's
and then
number 20,
this is
which
r
you're supposed
minus,
to do
or
in
9 minus 2,
Cylindrical
and then
coordinates.
a half, right? It's a negative.
Yes, but an R still
Yeah,
comes out,
AJ's.
because you guys still have to take the du with that.
Yes.
AJ's.
So same process
So this,
here,
the r cancels out.
the R would cancel out in the full integral. So the
Mhm.
R, technically the R is not there, so then you got that to the 3 halves. So it's,
Okay. So it's 2 pi times 9 minus
Now
r
let's see what's going on
squared.
on the other side of the board.
and then the reciprocal, so 2 then becomes 4 all over 3.
Yes.
Like to get the camera
And then
angle
when you
again.
take the du of the R squared of negative 2,
This is, no, it's
the
not.
negative 2R comes out, so this would have to be to the negative, and that would be a 6.
Can I give you my ID and you can do my practical exam for me?
They have to do the 0 also.
I think we need to call security on this.
I would call security to keep putting our pictures on YouTube.
Security asked me to.
So yeah, the final one would be negative 4 pi 9 minus R squared to the 3 halves all over 6. If I'm correct.
Okay, it sounds good, RJ.
That's the negative.
Did you intentionally just call him RJ?
I mean, huh?
Did you intentionally?
AJ.
So
No, I meant to say AJ
evaluate
and I said
at
RJ.
2 and 0.
Who's RJ?
4 pi
I mean, we have a right to
And you
know.
sub out
We
to-
spent 8 weeks together. Who's RJ?
negative 4 pi.
It's negative 8 times 9 minus 4.
Pardon me, sir, I'm going to rotate the back for you.
No, I already did, what was that?
So this is now copacetic,
Where is that?
all repaired?
What? Did I?
But I
Okay.
didn't
Finish
do the
10?
integral.
That's okay. Well, let's do this.
Yeah, the total final integral should be negative 4 pi this all over 3 halves. I did the R first before I did the theta, so it looks different.
So here we have number 11.
So
Which
that's, yeah, it's
is
negative.
This is negative
By
4, which is negative
Making a
2
drawing
thirds.
and understand what's going on.
2 thirds.
So it's number 11.
Okay, so it's
Right?
9 minus 4, which is
Do you guys want
Five.
Do you guys want the
So
real
five.
integral for that?
125 divided by
The real
2.
integral.
You guys are doing
25.
the integral of just the square root of 9 minus r squared, right?
what are you talking about?
Yeah, that's what we were doing
Do
earlier.
you want the real integral?
What is it?
It is.
You probably have some really answer that. I
It
don't know.
is r over 2 square root of 9 minus r squared plus 9 over 2 arc sine r over.
We don't want no arc sine.
3.
Nobody would give one that. You're making that up.
It's
Well, no,
number-
It's number 74.
get version 10, will you?
All right.
Get the-
Do you mind if I look at your book?
Go ahead.
The square root, wait, what?
I don't know.
Okay,
We
so
were right
you got
here.
2 pi.
Oh,
pi
yeah,
pi
version
over
10 is totally different.
2 pi
This is-
5,
If
Three
we get
halves
our
over
first
three.
here, then
Here's
and
your-
that's 125. 5 times 5 times 5, 25 times 5
I
It's
can't do
125.
three times, I don't even know what that
is 125, and then
If you do
125
the R
is
first,
squared
I
is
squared
25.
here.
Well, you
Yeah,
make the
it's 5.
substitution.
Yeah.
Square root.
25.
You
5 square root of
plus
5?
this.
Yeah, so it should be negative 5 square root.
So
of
it's u to
five.
the 1/2 to u.
Yes.
Oh,
So you
something
can
like that.
integrate that,
So
it's
like
u
it should
to
be
the,
negative 10
Three
pi
halves.
square root of 5.
So I have
So this equals
r
what?
squared plus z.
Negative 10 pi square root of
Now you
5.
write u equals r squared plus z
Oh,
squared.
square root of
that's
5.
right.
Yeah, but then you still have to take the 0 away.
The
So then you
UDR
have
equals,
9 3
But I
halves.
have z there.
that's a constant,
Oh, minus?
it's like a number
Yeah,
7
minus.
to
Oh,
9.
because this becomes a 0.
Think of it as
So
a
that's
9
7
times
or
9 is
9. It's just
81
some
times
number.
9 is 729.
So
9
r.
That's
times
right.
81.
9 times
That's what
81.
partial integration is,
729.
729.
okay?
Yes, say yes.
That's how you do it.
I can do that part. I can
Yes,
I
yes,
can
yes,
use
I
my
know.
head.
8
On
times
that.
9 times 10 plus
Yeah.
9.
Only the 729 because the 7 and 2 make
But-
9 and
so
this
now
at
you
9,
can do
so that's 99.
Well, 8 and 1, and then 1
As long
times
as-
9 is
as long
9,
as there are
and then 8
nines
times
in
9
there,
is
it
72.
is 9.
That was my problem.
So
Okay.
here-
That's
here's-
my rule
here's
for
the
nines.
integral. That's what it should look like. You guys did 9 minus r squared, right? So everywhere you see an a, replace it with 3.
I think
Yeah, but
Stuart
no one
should
wants
get
to
a
do our
Purple
sides.
Heart for doing the course of the wrong book.
I should get what?
A Purple Heart.
I got a purple heart for being stabbed with the flag.
Stabbed with a flag.
By an enemy combatant?
No, by his drill
Well,
mate.
if you...
By his what?
Drill mate in
No,
ROTC.
actually, it was caused by the other school's football player who
Sure.
accidentally
You guys had a
hit the
brawl?
flag.
You guys had a
No,
brawl?
he hit the flag on accident, causing
On
the flag to
accident?
fall and stabbing me.
I think he knew what he was
Going on
doing.
YouTube for,
Yes.
Deformation of the flag and just throwing it around while fighting at a high school event.
Well, I hope you suitably punished him. Okay, now we've gotten all the mileage that we can.